Morning, guys. Happy Tuesday to you. I hope you had a great weekend. We're going to go over the structure of a building today, the primary features of it. An introduction to structural design. Victor Hugo said, "An architecture has recorded the great ideas of the human race. Not only every religious symbol, but every human thought has its page in the vast book." So, when we're looking at the structure of a building, the primary function of a building structure is to support and transmit the building loads and forces to the ground. So, different characteristics of a structure. It's got to include the strength, which is the capacity of a structure to carry the loads applied to it. The stability means the structure can maintain its shape when the loads or forces are applied. Loads and disturbances to the structure should not produce larger movements or failures. The economic value. The economic value or cost effectiveness of the structural design depends on choices made regarding how the structure will carry the loads, the structural system used, and the materials chosen. The structural system is made up of many smaller structural subsystems that work together to provide a strong, stable, and cost-effective structure. Examples of these smaller structures and subsystems include the roof, the walls, the floors, the framing, the foundations. Of course, the foundations would be under the ground. Structural engineers design these structural systems. They're made up of many structural elements that work together to provide a strong, stable, and cost-effective system. Basic structural elements include beam, columns, trusses, arches, vaults, and domes. Structural engineers design these structural systems to work together. Forces and loads. A force is any action that causes a change in the shape or motion of an object. A load is a force that is supported by a structural element. The terms force and load are often used interchangeably, though. Each structural element is subjected to at least one type of load, though, and loads include people, furniture, equipment, wind and snow, earthquakes, floods, and soil pressures. Soil pressures pushing back up against the load. Structural member forces. Tension is a force that stretches or pulls apart a member, resulting in the member elongating. Compression, a force that squeezes or presses members together, resulting in the member shortening. Shear is a force that acts perpendicular to the axis of the member, causing the internal particles of the member to slide against one in each other. So a beam, a structural element that carries a load that is applied transverse, perpendicular to its height. Usually a horizontal member that carries a vertical applied load. The top fibers of a beam are in compression, and the bottom fibers are in tension. Many structural members within a structure are technically beams but are called something else. For the examples, joists, girders, elevated slabs, they'll act as beams. Cantilever beam, a special type of beam that is supported only at one end. The top fibers of the cantilever are in tension and the bottom fibers are in compression. A column is a vertical structural element that carries an axial force in compression. And a truss is a structural element that is composed of smaller structural members, typically configured in triangular arrangements. Some truss members can carry a tension of force and others can carry a compression force. As where an arch is a curved structural element that spans an open space. In stone arches, the last stone to be placed in at the top is called the keystone. It's in blue here in this diagram. A continuous arch that forms a ceiling or a roof is called a vault dome. And a dome is a structural element that is made up of arches that radiate around a center point to create a half sphere. And you've got hybrid forms. There's an infinite number of combinations of these forms that exist. A space frame combines 3D trusses in the form of a dome in the picture to the left. And then this picture combines curved beams with metal roofing to form a vault. The design process, the same design process used by engineers and designers in other disciplines, can be used to design a structural system. Architects and engineers use an iterative process that you guys learned about in IED to define, analyze, and solve the problem of creating a strong, stable, and cost-effective structure. The same process used by engineers and other disciplines can be applied to the design of the structures. Remember that a design process is never linear. If at any time you discover new information or new constraints are placed on the design, or you come up with a better idea, you may need to return to an earlier step to incorporate the new information. For the most commercial projects, an architectural program is created by an architect or by a design team that may include many different types of design professionals. The architectural program is the foundation on which the design of the building is defined. This program establishes the overall concept, philosophy, and design approach for the building. The specific building design problem is established, ideas for the buildings are brainstormed, research is performed on the, I didn't want to leave that yet, is performed on the existing building, solutions and new technologies that can inform the decisions for this project. The specific criteria and constraints for the building are defined. The architectural program is in essence a design brief for the design of the project and typically includes preliminary drawings. The architectural program is shared with other professionals involved with the design, including the structural engineer, who will design the structural system to support the building design. The architectural program typically identifies the general structural systems that will be used to support the building. For instance, the architectural program would establish the types of walls, floors, roofs, and often the structural frame of the building. The structural engineer has the responsibility of designing the specific elements of the system to safely and effectively support the building and the loads that will be applied to the building. Once the architectural program is established, a structural engineer must further design the loading criteria of the structure. The structural engineer must know exactly what types of magnitudes of loads to consider in the design of the structure and how each load will be carried and transferred through the structure to eventually be resisted by the ground. Once the load to each structural member has been established, options to resist the loads can be explored. For instance, you may want to explore the possibility of using both hollow core precast panels and composite concrete floors. If structural steel floor framing is to be used, you may want to consider both open web steel joists and structural I-beams. There is opportunity to adjust spacing of structural members, such as floor joists and columns if necessary, to improve the redesign and to reduce the cost. The design's got to be selected for every structural element in the structural system. You got to develop a design proposal, create a preliminary structural design incorporating the selections for all the structural elements. Model or prototype it. For structural designs, prototypes are not often practical. However, structures are very often modeled in structural analysis software or 3D architectural programs to check structural behavior and compatibility with other building systems. Simply choosing a structural element slightly different from that originally assumed may change the loading conditions and affect the structural performance of an element. Therefore, you should always reanalyze each design to ensure its strength and stability if new conditions are present. For example, assume that you choose the joists that weigh 20 pounds per foot of the member for the preliminary analysis. However, the preliminary member did not provide adequate strength to carry the adapted loads. You therefore had to choose your selection, and you choose a member that weighs 25 pounds per feet. The increased weight will affect the design, and the member should be reanalyzed to make sure it can carry the additional weight. Structural analysis software can check the strength and stability of a structural system, including all of the individually designed structural elements. And eventually, you refine the process, revise the design, and as necessary to correct problems with strength, stability, and compatibilities with other systems. You create it, make it based on the final decision. After the revisions, create working drawings of the structural design to make sure that all the paperwork and documentation coincide with each other. Then you communicate the results, distribute the drawings, include a bid package, include in-construction drawings, and that's it. I will have the paper up for you guys to answer a few questions on, along with this PowerPoint, and then the rest of the day you can spend working on your term papers. Check back in with me tomorrow, guys, and have a great day.